Hybridization. Hybridization concept was developed by Linus Pauling in 1931. It is defined as the redistribution of orbitals of almost equal energy in individual atoms to give equal number of new orbitals with identical properties like energy and shape. Here, the resultant new orbitals are called as hybrid orbitals. Let us take three types of hybridizations formed by carbon atom. sp3 hybridization, example methane, that is CH4. sp2 hybridization, example ethene, which is C2H4. sp hybridization, example ethyne, which is C2H2. sp3 hybridization. The atomic number of carbon is 6 and its general ground state electronic configuration is 1s2, 2s2, 2px1, 2py1, 2pz0. The carbon atom in the ground state takes up some energy and goes to the excited state. In this process, a pair of electrons in 2s orbital splits up and one of the electrons from this pair is transferred to empty 2pz orbital. Then, the excited state has 4 half-filled orbitals and electronic configuration is 1s2, 2s1, 2px1, 2py1, 2pz1. In the excited state of carbon atom, 1s orbital, which is 2s, and 3 p orbitals, which are 2px, 2py, 2pz, intermix and reshuffle to form 4 identical orbitals known as sp3 orbitals. Here, carbon has 4 unpaired electrons, which is capable of bond formation with other monovalent element or other 4 carbon atoms. When carbon interact with hydrogen, 4 hydrogen atoms consisting of 1 electron in their s orbital allows their electrons to overlap axially and separately with the 4 sp3 orbitals of carbon atom and forms 4 sp3s sigma bonds with equal energy. The 4 sp3 hybrid orbitals are directed towards 4 corners of regular tetrahedral with bond angle 109 degrees 28 minutes. sp2 hybridization. In ethene or ethylene molecule, carbon atom forms 2 single covalent bonds and 1 double bond. It can be explained with sp2 hybridization. The excited state of carbon atom has 4 half-filled orbitals and its electronic configuration is 1s2, 2s1, 2px1, 2py1, 2pz1. In excited state, 1s orbital, that is 2s, and 2p orbitals, that is 2px, 2py of carbon intermix and reshuffle to form 3 identical sp2 hybrid orbitals along with 1 unhybridized p orbital, that is 2pz. 3 sp2 hybrid orbitals with 1 electron each get separated around the nucleus of carbon atom at an angle of 120 degrees. In the formation of ethylene, each carbon atom is hybridized with 3 sp2 hybrid orbitals. 1 sp2 hybrid orbital of carbon overlaps with sp2 hybrid orbital of another carbon and forms sp2-sp2 sigma bond. For the remaining 4 hybrid orbitals, each carbon atom overlaps with 1s orbital of 2 hydrogen atoms and form 4 CH sigma bonds. Unhybridized orbital, that is 2pz of both the carbon atoms, overlap laterally and form 1 pi bond. Hence, a double bond is formed between 2 carbon atoms in ethene as shown here. Double bond consists of 1 sigma bond and 1 pi bond. sp hybridization. In ethyne or acetylene molecule, There exists a triple bond between two carbon atoms and a single bond between carbon and hydrogen for two carbon atoms. It can be explained with sp hybridization. The excited state of carbon atom has 4 half-filled orbitals and electronic configuration is 1s2, 2s1, 2px1, 2py1, 2pz1. In excited state, one s orbital, which is 2s, and one p orbital, which is 2px of carbon intermix and reshuffle to form two identical sp hybrid orbitals with two unhybridized p orbitals, which are 2py and 2pz. In formation of ethyne molecule, one sp orbital of a carbon overlaps with sp orbital of other carbon and gives sp-sp sigma bond. The other sp orbital of each carbon atom overlaps with s orbital of a hydrogen atom and forms s-sp sigma bond. The unhybridized p orbitals of one carbon atom laterally overlaps with unhybridized p orbital of other carbon atom to give two pi bonds between two carbon atoms, that is pi py-px and pi pz-pz bonds. Thus, in ethyne molecule, there exists 3 sigma bonds, that is 1 sp-sp sigma and 2 s-sp sigma, and 2 pi bonds, that is py-py and pz-pz pi in the molecule.